The next session is called So You Think You're an AWS Master, or as I would like to call it, Serverless Computing on AWS. So if you joined the keynote this morning, you heard maybe Glenn Gore mention that there will be more and more focus on serverless computing. And I'd like to show some of those to you today. And this content I developed together with my colleague Olivia Klein, who's a solution architect at AWS. So it's all about speed. No matter what business you're in, it's all about speed. Speed wins in business. In order to have speed and agility, you need to focus on your application. Everything else is undifferentiated heavy lifting. So what you actually need to do is move the screen, so we see the whole screen. Technical team, please, squeeze the screen a little bit. What you need to do is move up the stack. By moving up the stack, you are abstracting away more and more of the underlying undifferentiating layers. Now, let's take a look at the application architectures a little bit, how to do this. Squeezy, squeeze. So what you don't want to do anymore is this. You don't want to make anymore a tightly coupled, monolithic monster of an application, a huge jar file with all your components inside. It's an unmanageable mess, it's fragile, it doesn't scale. What you need to do, what you should do, what many people do these days, is decompose your application into its building blocks. So let's start defining your application building blocks that comprise your end solution. And you might need a lot of things. You might need things like compute, storage, load balancing, databases, identity and access management, content delivery network. Nice, you need all those things from IT, but they are not differentiating your application. Your application, your solution, your product is defined by your cool features that you develop. So you should focus on those. You should focus, can you please squeeze, so we can see the whole screen? Thank you, technical team. You should focus on your core differentiators. And you should offload the undifferentiating ones to services. So that's why we have in the name of our company services, Amazon Web Services. So we have a range of services in our portfolio, around 40 services currently. And the point of those services is exactly that you can offload the undifferentiated heavy lifting of IT, infrastructure, and platforms to those services. Now, you are probably aware and familiar with the fundamental core services on the bottom. Compute, you can provision virtual machines, storage, networking, etc. Those are fine, nothing wrong with that. However, you still need to then manage your servers. You need to make decisions on things like which operating system should I use, what packages should I put on my server, etc. However, when you use the higher order services, what we call the platform level services, they provide you more value, they abstract away more of the underlying infrastructure, and they let you focus more on your activity. They automate more. So let's take a look at some of the services you may be able to use to build out these serverless systems at large scale. Let's start with the data tier, the bottom tier, typically the most difficult tier to scale and manage. Here we have Kinesis. So Amazon Kinesis is a real-time streaming data service allowing you to ingest any amount of data. So with Kinesis, you can have hundreds of thousands or millions of devices or entities producing data, pumping your data into Kinesis. Kinesis will ingest it, replicate the data across multiple availability zones for durability. You don't lose a single record. And on the other side of Kinesis, it provides an ordered stream of data that you can then consume with your real-time analytics applications. And you can plug in multiple applications, multiple use cases to the same Kinesis stream. So Kinesis is really the way to pump a lot of data into the cloud, one of the ways. Where do you store it? Amazon S3, it's been around. However, it is still a crucial element for the object storage, storing files and objects. S3 provides unlimited storage capacity, 11 nines of durability. You don't have to do capacity planning, and it scales horizontally, and it's very easy to use. So let's talk more about the application tier. I was complaining about the monolithic applications. What could you do now, today, with AWS? Well, at reInvent last year, we introduced one of my favorite services, our brand new compute service, Aws Lambda. So Aws Lambda is an event-driven, fully managed compute service. Basically, all you need is code. There is no infrastructure to manage. When you use Lambda, all you need to do is code your function that you want to execute, and you tell the cloud when you want to execute it. You can attach it to an event, such as I have a new file, new object in my S3 bucket. I have a new piece of data record in my Kinesis real-time data stream. Something has changed in my DynamoDB table. Somebody has made a new entry in the table. You can attach a cloud function with Lambda and compute against those events. Compute against the data the moment the data arrives in the cloud or is being generated. Nothing to manage, no operating systems, no servers, no high availability to manage, no auto-scaling even. Lambda takes care of everything. All you need to do is provide your code and Lambda executes it. And it scales automatically to any scale. So it doesn't matter if your function has to execute once a day or 1,000,000 times per hour. Lambda will execute it in milliseconds, and it is impossible to over-provision or under-provision your system. You don't provision. Lambda simply runs your code whenever the event that you are interested in happens, or whenever you call the Lambda function. Lambda is super fast. It executes your code in milliseconds at any scale, and it's extremely cost and resource efficient. Now, with Lambda, there is a generous free tier, and after that, you are built at 100 millisecond granularity of compute chunks. 100 millisecond granularity. So for example, if your function execution takes 150 milliseconds, you are built for 200 milliseconds. That's it. That's all you consumed. It's very fine-grained. So that's all fine, but I said earlier, you don't need servers. So how do we get around that? Well, one way is to start making two-tier architectures for your application. A traditional architecture would be three-tier. On the left-hand side, you have your clients and customers using your service. Then you have a server tier that you manage, probably with elastic load balancing, auto-scaling, to respond to the demands and needs. And behind your servers, you then have the rest of your services, like your databases, your storage system, etc. That's fine. But what we could do nowadays is this. Dump the server tier. Execute your code directly on the customer device, for example, on the browser, maybe on an IoT device with our IoT SDK. And with the AWS SDK directly running on the customer device, your code on the customer device scales horizontally with the number of clients, and each one of the clients can go directly to the AWS backend services where you run your backend system. Securely, authenticated, access control, fully horizontally scaling. And crucially, you don't have a server tier to manage at all in this scenario. So one example is the AWS JavaScript SDK for browsers. That lets your browsers, mobile or desktop, laptop, execute your code, JavaScript, on the browser and have the AWS libraries to interact with things like DynamoDB, S3, and the rest of the services. How do we deliver your application to the customer in this scenario? For example, with S3. So Amazon S3 is not just a storage system or service. It's also able to deliver content to the customers over the web. And of course, you can accelerate and cache this delivery, scale out globally by using Amazon CloudFront CDN in front of that. So that's a simple way to deliver your application to the customer devices. Fine. We need state. Lambda functions are stateless. They execute when the event happens. It's fire and forget. They execute, they do something with the data, maybe build the new data somewhere else. Where is the session state? Where is the gaming state? Where is the shopping cart? For example, here. So when you use AWS Lambda, Lambda functions are stateless when they execute. They are small, they are fast, they are fire and forget, instant amnesia. You have to keep the state somewhere else. And the recommendation is to keep the state in another service that is fast, durable, highly available, for you to get the session state and update it. DynamoDB is perfect for that. So DynamoDB is a NoSQL service, which is zero administration. You don't install DynamoDB. You simply create tables, you define your indexes, and then you specify the performance, the throughput that you need from your tables. And you can change that while you're in production, more and less. DynamoDB provides unlimited storage capacity and provision throughput and at consistently fast speed, single-digit millisecond response times. So this is a great place to keep the session state, one example. So now let's go to a demo. And this is the demo system that we are going to be building together. Doesn't have any servers. So we are going to be running the application on my browser with the AWS JavaScript SDK. We will deliver the JavaScript to my browser from S3 directly, no web servers needed. We will authenticate with Facebook. Once I'm authenticated as an administrator, the cloud will give me temporary session keys so that I can securely authenticate it, have access control to those granular resources that I need. So once we are authenticated, we get keys from the cloud, and then the JavaScript SDK application can manipulate DynamoDB directly, store files in S3. And then, this is a dynamic block application. If I upload a new block entry, the metadata goes to DynamoDB, and the picture, if I upload it, goes to S3. And then one more thing. There's a Lambda function attached to the S3 bucket. If there's a new picture in the S3 bucket, it kicks off a Lambda function that makes a thumbnail of that picture. So all of these services scale out fully horizontally, unlimited scale. So let's see the demo. So I will switch to my browser. Make it a bit bigger for you. So this is the particular bucket that I will be using for the demo. As you can see, it's currently empty. I have not deployed my application yet. Let's deploy it together. So here's my terminal. So on my laptop, I have the JavaScript application. You can see that there's index.html, there's some JavaScript, CSS, etc. And I have a little script here that simply uses the AWS command line tool to synchronize this directory on my laptop with that bucket in S3. And it sets the files to be publicly accessible because this is something that customers will need to access and download. So there we go. By executing this one command, we now should have deployed our application to the S3 bucket. So we have, if you will, deployed the application to production now. We don't have a server. We're using S3 service for delivering the application. Now we have the files in the bucket, the application. How do we deliver it to the customer client, my browser? When I select the index.html file, you can see that S3 is giving me a link. And of course, you could use Amazon Route 53 to put a nice host name and domain name for this application link then. So now when I click this link, what happens is that my browser now downloaded the file from S3 without any web servers. Now let's also show you the JavaScript console so you can see what happens. So now we are running the JavaScript on my laptop here. And let's now click the login button. Let's log in as an administrator. So, as you can see, there is a Facebook authentication that popped up. So in the JavaScript that we downloaded, for the login button, it directs us to Facebook. So let me now log into Facebook. And what happened on the top right of the screen is that the login button changed to log out, and there's a new button, post. So we are now logged in as an administrator, but how did that actually happen? Here. We'll zoom in so that you can see better. When I click the login button, then the JavaScript application contacted graph.facebook.com, which is Facebook's identity provider. And then when the login was successful, you can see that the JavaScript used AWS STS, Simple Token Service, to generate session keys for this browser, for this instance of the application, and it's associated with an IAM role, Identity and Access Management role. So first we authenticated with the provider Facebook. Once the authentication was successful, we then generated session keys, and they are attached to an IAM role for granular security. Let's take a look at that role. So here I have the same IAM role. This is the IAM console. How did the authentication happen? Well, there's a trust relationship. So we can see here that there's a trusted entity, facebook.com, and there's a particular application ID. So if you look at the application ID, it ends with 3131. If I go to my Facebook developer pages, you can see that the same application ID is here. So all I needed to do was register an application in Facebook. Facebook generates an application ID. I copy that, and I put it in AWS IAM console for this particular role. That is the trust relationship. So now IAM trusts Facebook for this application. Facebook says, yes, he is who he says he is. And then the rest of the IAM role has the policies that I can access a DynamoDB table and the particular S3 bucket, but nothing else. So that was the authentication. Let's now create a block entry directly from the browser. But first, let's see what we have. So in S3, we only have now the application. We don't have any pictures. We haven't uploaded any. There is a DynamoDB table as well. So this particular application has a DynamoDB table, but when I scan the table, DynamoDB tells us the table is empty. There is nothing there. So let's create a new block entry directly from the browser. I click on Post. Hello, AWS Summit Singapore. Some text. This is a Porsche 917K. And let's attach a picture from my laptop. My favorite racing car from 1970. So I select the picture from my laptop. We are running the JavaScript on my browser. I click the Publish button, and now the JavaScript on my laptop with the keys that we generated automatically with the IAM role that allows access to the S3 bucket and DynamoDB should be able to upload this block entry to our system in the backend. So there's the block entry, and when we look at the console here, JavaScript console, we can see that a couple of things happened. There is an AWS S3 JavaScript call, put object, so create a new object in the bucket, 917 medium.jpg, it's an image JPEG, so it uploaded the picture, and AWS DynamoDB put item, where the JavaScript put the metadata, the text that I wrote, to the table. So using the keys and the policies, we are able to do that. Now when we scan the DynamoDB table, we can see that there is an entry here. It has the text that you saw. This is a Porsche 917. So the JavaScript on my browser is now able to communicate with DynamoDB directly and securely. And when we look at the S3 bucket, we can see that there is an asset. There is a picture. This is the picture of the Porsche. So it was uploaded by my browser to that S3 bucket using the keys and policies. And there is something else. There is a thumbnail. There's a little picture. That's only 2 kilobytes. How did that come there? AWS Lambda. So now I will show you AWS Lambda. When I select the bucket itself, and I look at the properties of the bucket, I have defined an event in this S3 bucket. The event is, if there is a new object created in this bucket, it executes a Lambda function called S3 create thumbnail. So the moment there's a new object in this bucket, like the picture uploaded, it executes a Lambda function. Let's go to that Lambda function now. So this is the console of AWS Lambda. It's very easy to use. All you need to do is upload or code your functions, attach them to events, and that's it. So, by the way, look at this. I have 5 Lambda functions. So I have 5 different code things in Lambda. They are only 2.9 kilobytes of storage. They are 2.9 kilobytes. This thumbnail function is less than 1 kilobyte in size. You can specify the memory that you allocate to this function execution, and then a timeout. Lambda will retry, and it provides you monitoring, CloudWatch monitoring, for example, for the average duration of the execution. So this one, on average, has taken 212 milliseconds to execute. So then you can tune your memory and your timeout values accordingly. It provides you logs, so obviously you need to do some troubleshooting. So if and when you are coding Lambda, you want to see what's going on, you can see that in CloudWatch logs. Now the logs are ordered by time of creation, and we can take you directly to the right log file for that Lambda function. So you can easily find the events. So you can output your debug log outputs here. You can see what's going on. Good. How does that function look like? You can also do unit testing and development directly in the Lambda console. Unit testing means that you can invoke the function directly from the console, basically simulating the event that actually happens like a new file. But this is what I wanted to show you. This is the Lambda function that creates the thumbnail. We load the AWS SDK. This is Node.js. We make an S3 client. And we use also the ImageMagick external library. You can bundle your external libraries with your code in a zip file and upload them to Lambda. This is a very simple function. It gets the file, the new file that was put in the bucket, and then it calls the ImageMagick resize function to make a small version of the picture. If that is successful, it uses the AWS SDK to put the thumbnail as a new object back in the same bucket with the name thumbnail minus original name. And that's it. It's only 56 lines of code. That's the point of Lambda, small, little cloud functions that are useful. So let's do one thing. Let's delete this block entry. Now it's gone from this block. We go back to DynamoDB. We scan the table again. Done. It's empty again. So that was the first demo. A completely serverless system, JavaScript SDK, S3, DynamoDB, and Lambda, and Facebook authentication. That was an example of an asynchronous Lambda call, asynchronous call. Something happened, there's a new file, picture of a Porsche, it kicks off a Lambda function that does its thing, and then it's done. But customers were asking, when we introduced Lambda, they wanted to have synchronous Lambda calls. Synchronous call means that you can call Lambda and wait for the response. Basically, you can offload compute to Lambda directly from your code. Now, this is interesting. It works like this. Let's say again that you're running, for example, the AWS JavaScript SDK on the browser. You have functions that you have defined in your JavaScript. They execute on your browser nicely. One of the functions happens to point to Lambda. So you can program Lambda to do stuff for you in your application, just like if it was executing locally. You just call a Lambda function. The SDK makes a request to Lambda. Lambda executes your function and gives a response back to your code, to your application. And if you need to, you can use all the other AWS services behind Lambda. So your Lambda function can use the AWS SDK, for example, the Node.js SDK, to use DynamoDB, S3, SQS, SNS, Kinesis, whatever it needs. So basically, with this synchronous Lambda call, your application running on the customer browser has an unlimited scale supercomputer, if you will, executing in the background with AWS Lambda. All you need to do is call Lambda functions. Here's an example from the AWS JavaScript SDK of calling an external Lambda function in synchronous mode. So we load the AWS SDK JavaScript. Then we make a Lambda object here, new AWS Lambda object. And all you need to do after that is to invoke a Lambda function. You tell Lambda which function you want to execute. you give it some payload, and that's it. You get a response from Lambda, and you continue working. Lambda can do the supercomputer stuff in the background using the capacity of the cloud. So the second demo I would like to show you is exactly that. Let's take a look at synchronous function execution with AWS Lambda. It's similar to the previous demo. We are still going to use the browser, AWS JavaScript SDK for the browser. We are going to deliver the JavaScript application from S3 to the browser, just like you saw earlier. But after this, the application running on the browser is only communicating with Lambda. It's only calling help from Lambda. Lambda, in the background, can use the rest of the services, like DynamoDB and the simple notification service. All the application needs to do is call Lambda functions. Lambda will handle the rest of the cloud behind the scenes. So let's go to this demo. OK, this is the second bucket. Just like you saw earlier, I use S3 to deliver the application to the browser. So this is the second application that uses synchronous calls. There is a link there, and I have already it open here in the Firefox. And I ignore the update, go away. There you go. So this is the second JavaScript application now. It says it's an AWS Lambda demo. We can load some comments. This is also a block system. It's a different one. We can post some comments. And what I have opened here on the bottom is the network monitoring developer tool. But before we do anything, let's take a look at the code. The code that is now running on my browser. Make it a little bit bigger for you guys. OK. So this is the JavaScript running on the browser right now. It creates a new Lambda object, and then we have a couple of buttons on the screen. There's a load comments button. If we click that button, it invokes a Lambda function called getAllPosts. So when we click the button, it invokes a Lambda function, and Lambda is supposed to get the block comments from somewhere. We will see later from where. Then Lambda responds with the data, or potentially an error if something goes wrong. If it was successful, the JavaScript will simply insert the new comments to the web page that we are viewing. So get the data from Lambda and then display them on the screen. Let's go to the actual code in Lambda. So remember, if we press the button, it executes a Lambda function called getAllPosts. OK, where is that? GetAllPosts. This is the Lambda function. You can see some metrics there, invocations, execution duration. Let's take a look at the function itself, getAllPosts. So if I press the button, the JavaScript is calling that Lambda function, and it executes this code. What does it do? It creates a new DynamoDB object, and it makes a query to DynamoDB and gets the block comments from DynamoDB. So the JavaScript application doesn't have to do it. It just asks Lambda, can you please give me the latest block comments? The Lambda function uses the DynamoDB object and communicates with DynamoDB. And then, when there's a response from DynamoDB, the Lambda function will return the comments. They go back to the JavaScript code, which is then displaying them on the screen. So let's see how that works. Let's see what we have in DynamoDB first. Do we have any comments in the DynamoDB table? So in DynamoDB, I have a table called Lambda Demo Posts. Let's go to that table and scan it. We have 2 comments already in the DynamoDB table. AWS IoT Hack Day was awesome, and I look forward to the AWS Summit Singapore. So the table has some data, some comments. Let's go back to the application and click the button, see what happens. Now, if you look at the network monitoring here, you saw that when I click the button, the JavaScript running on my browser talks to lambda.uswest2.amazonaws.com. Send a JSON object there, and then there's the response times. So the application running my browser only talks to Lambda with a Synchronous function, gets a response, and then is able to take from the Lambda response the payload and then display them on the screen here. So Lambda used DynamoDB in the background. Let's make a new comment. If I post a new comment, what happens? There's another piece of JavaScript code on the browser. If I click the post button, it takes the text that I wrote and calls another Lambda function, create new post, and then sends the payload of the text that I wrote to that Lambda function. On the other side, in AWS Lambda, what happens if we call that Lambda function? Create new post. So if we get a call in Lambda for this function, create new post, it makes a DynamoDB object again and a simple notification service object. The first thing that the Lambda function does is that it takes the payload, the text that we write, and it puts them in DynamoDB. And if that was successful, it will also send a notification to the simple notification service. With Amazon SNS, you can deliver notifications to things like email, other applications, or mobile devices. And I have registered a topic in Amazon SNS, Simple Notification Service. This is the topic where we should get the notification. And I have two subscriptions. I have my email and my phone. So the point is that if there's a new block entry in that table, in that block, I want to be notified on my phone and my email. Let's see what happens. Let's go back to that client browser. This is a new comment on my dynamic block. Click Post. And what happens here in the network monitoring is that we invoke Lambda function, and something happened on my phone. Hello? I got a notification message on my mobile phone. New comment, this is a new comment on my dynamic block. So the same text, it was delivered as a push notification on my phone. It's visible here on the block itself. And if we go to my email inbox, there is a new email, AWS notifications, new comment on AWS Lambda demo. This is a new comment on my dynamic block. So I got an email through the SNS service, and I got a push notification on my phone. And in DynamoDB, if we scan the table, we should have one more entry here. There you go. This is a new comment. So that was a quick demo showing the synchronous calling of Lambda functions. Just to recap, we delivered the JavaScript to my browser, AWS JavaScript SDK for the browsers. It only communicated with Lambda. Lambda used in the background, the Lambda function used DynamoDB and Simple Notification Service to work with the backend system. But for the client, only communication from the local code was with Lambda functions. So we offloaded compute and logic to Lambda and the rest of AWS. Because servers are just so last season. That was my presentation. I really hope that you enjoyed serverless computing. Thank you.